Hello students, today in this video we'll solve a problem on matrix. That is, we are going to find the value of eigenvalue and eigenvector for the given matrix here. As you can see, the given matrix is 3 cross 3 matrix. So 3 cross 3, it means we have 3 rows and 3 columns. So since this matrix is 3 cross 3 matrix, we'll have 3 eigenvalues and 3 eigenvectors. So let us solve the given problem. So I'll consider the matrix to be the matrix A. So let A equal to the matrix 2, 0, minus 1, 0, 2, minus 2, 1, minus 1, 2. To find the eigenvalue, first I need to write the characteristic equation. The characteristic equation to find the eigenvalue is mod A minus lambda I equal to 0. So this is my characteristic equation. So to find the eigenvalues, I need to write the characteristic equation. So the formula to find the characteristic equation is mod A minus lambda I equal to 0. I know the matrix A, so matrix A is given. Next I am going to write the matrix I. So matrix I is nothing but matrix I is an identity matrix. So since this is 3 cross 3 matrix, then the identity matrix will be 1 0 0, 0 1 0 and 0 0 1. So this is my identity matrix. Now I will find the value of A minus lambda I. So A minus lambda I will be equal to, the matrix A is nothing but 2 0 minus 1, 0 2 minus 2, 1 minus 1 2. So this is my matrix A minus, according to the formula, I need to write the value lambda into the matrix I. The matrix I is nothing but 1 0 0, 0 1 0 and 0 0 1. Now I am going to multiply lambda inside the matrix. So I'll write this matrix as it is here. So this is 2 0 minus 1, 0 2 minus 2, 1 minus 1 2, minus, I am going to multiply lambda inside the matrix. So lambda into 1 is lambda. Lambda into 0 is 0. So I'll multiply the terms. Here it is lambda 0 0 0 lambda 0 0 0 lambda. Now I am going to subtract both the matrix. So while subtracting the matrix, I'll write here the first element is 2, the sign given is minus, and in the second matrix the first element is lambda. So 2 minus lambda, 2 minus lambda. Next, to find the next element, here the second element is 0 minus sign, and then here in this matrix the second element is 0. So this is 0. Similarly, I am going to find the third value. Here the first element is minus 1, sign is minus, and the third element is 0. Similarly, I am going to find all elements. So here it is 0 minus 0. Next 2 minus lambda. Next minus 2 minus 0. And next element is 1 minus 0. Minus 1 minus 0. 2 minus lambda. So I'll get the value. So A minus lambda I will be equal to the matrix 2 minus lambda 0 minus 1 0, 2 minus lambda minus 2, 1 minus 1 and 2 minus lambda. So this is my A minus lambda I. Next, I am going to find the value of, according to the equation, as I need to find the eigenvalue, I need to write a characteristic equation. So the characteristic equation, as we know, mod A minus lambda equal to 0. So we have the value A minus lambda I. So I'll write the characteristic equation here. The characteristic equation is mod A minus lambda I should be equal to 0. Mod is nothing but the determinant. Okay. So I'll take the determinant of this term. So determinant 2 minus lambda 0 minus 1, 0, 2 minus lambda minus 2, 1, minus 1, 2 minus lambda. Okay, so the determinant part should be equal to 0. This is equal to 0. So now I am going to find the determinant of this matrix. So the determinant of this matrix can be obtained as, we need to consider the first row here. So according to here, the first row element is 2 minus lambda. So 2 minus lambda, I'll write this within a bracket, and I'll take 2 minus lambda into, so since I have taken the first element here 2 minus lambda, this value 2 minus lambda, it comes under the first row and first column. So cancel the first row and first column. The remaining matrix is 2 minus lambda, 2 minus lambda, minus 1, minus 2. So we need to we need to take the determinant of this matrix. So if I take the determinant of this matrix, the equation will be 2 minus lambda, 2 minus lambda. Multiply both the terms, 2 minus lambda into 2 minus lambda. Then put minus, then multiply both the terms. Minus 1 into minus 2 will give me plus 2. So this is plus 2. Okay, plus 2. So this part is over. And next, we take the second value. The second value in the first row is 0. So minus, put minus sign, then 0, then the matrix 0. So this 0 comes under first row, second column. So cancel the first row and the second column. Then the remaining matrix is 0, minus 2, 1, 2 minus lambda. So if we take the determinant of this matrix, we'll get 0 into 2 minus lambda. So 0 into 2 minus lambda, 0. Then put minus sign. 1 into minus 2 is minus 2. Minus 2. And then we take the third element. The third element, it is given minus 1. So I'll write minus 1. Whatever it is given, I'll write here. So minus 1. If it is plus, I'll write plus. If it is minus, I'll write minus. So minus 1. So I'll cancel the first row and the third column. I need to find the determinant of the remaining matrix. 0, 2 minus lambda, 1 minus 1. So 0 into minus 1 is 0. Minus 1 into 2 minus lambda, 2 minus lambda. So 2 minus lambda. So as you can see, the determinant value is equal to 0. I have found the determinant now. So this determinant will be equal to 0. So now I am going to multiply the values here. Okay. First find what is the value coming inside the bracket. So I will write the value 2 minus lambda, which is outside the which is outside. Write it as it is. Now find this value. 2 minus lambda into 2 minus lambda. Multiply the value 2 into 2 and then 2 by minus lambda. So if you multiply 2 into 2, it's 4. Then 2 into minus lambda is minus 2 lambda. Then multiply minus lambda by 2. Minus lambda into 2 is minus 2 lambda. Minus lambda into minus lambda is nothing but plus lambda square. And then we have the value here minus 2. So minus 2 will be written as it is. Minus 0 into the matrix. 0 into anything is 0. So 0 into anything is 0. So I'll write it as it is 0. And then minus 1 into, this is 0. 0 value is nothing. I'll take minus inside here. If I take minus inside, it will be right like minus 2. Minus into minus is plus lambda. So if I take minus inside, plus will become minus and minus will become plus. So this is plus, so it becomes minus. This is minus term, so it will become plus. So the value equal to 0. And then we can write this equation as, we can rewrite it as 2 minus lambda, write it as it is. First take the bigger term. So the bigger term is lambda square. Lambda square, take it outside. Then minus 2 lambda will give me minus 4 lambda. And then 4 minus 2. 4 minus 2 is nothing but 2 plus 2. Then the second term is minus, leave it. And then we have here minus 1. So minus 1 into minus 2 plus lambda equal to 0. So now we are going to multiply this term inside the bracket. So if we multiply 2 by lambda square, it is 2 lambda square. 2 by minus 4 lambda. 2 into minus 4 is minus 8. 2 4s are 8, minus n is the minus, so minus 8 lambda. 2 into 2, 2 into 2 is 4, so plus 4. Now we need to multiply lambda inside here. So minus lambda into lambda square is minus lambda cube. Minus lambda into minus 4 lambda will give me minus into minus is plus 4 lambda square. Then minus lambda into plus 2 will give me minus 2 lambda. And then minus, if I take 1 multiplied by minus 2 plus lambda, this is nothing but minus 2 plus lambda. If we take minus inside the bracket, the negative will become positive and the positive will become negative. So I am taking minus inside the term, so I'll write it as this negative will become positive, so this is plus 2 minus lambda. So this will become plus, this will become minus. So plus and minus. So the equation is equal to 0. So I'll write the equation is equal to 0. Now I'll write the bigger term. Okay, so bigger value here, as you can see from this equation, the bigger value is lambda cube. So lambda cube will come first. So here the sign given for lambda cube is minus. So minus lambda cube I'll write. Now we need to take the value of lambda square. Lambda square is given here 2 lambda square, and then we have here plus 4 lambda square. So 2 plus 4 is 6. So plus 6 lambda square. And then the next term is we need to take the values of lambda. So here lambdas are here minus 8 lambda, and then the lambda is here minus 2 lambda. Minus 8 lambda minus 2 lambda is nothing but minus 10 lambda. Minus 10 lambda minus lambda will give me minus 11 lambda. And then we'll take the constant term. The constant terms are 4 plus 2. So 4 plus 2 is 6. Plus 6 equal to 0. So we'll take, as you can see, the higher power has negative term. We'll take minus outside. If we take minus outside, the signs will change. So here minus lambda cube will become plus lambda cube. This plus will become minus. So minus 6 lambda square. Minus will become plus lambda 11 lambda. This plus will become minus. So minus 6 equal to 0. If we have power, if we have minus sign at the beginning of the equation, we can take it outside. So we'll take it outside. If we take it outside, the signs will change. Okay. So here, since this is minus, it becomes plus. Plus will become minus. Minus becomes plus, and plus becomes minus. Okay. So this is my characteristic equation. Therefore, the characteristic equation is lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. So this is my characteristic equation. So from the characteristic equation, I need to find the roots. So to find the roots of the characteristic equation, what I am going to do is, so since as you can see here, the power is cube, so we'll use the synthetic division method. Okay, so by synthetic division method, we'll obtain the value of lambda now. So to solve by synthetic division method, we are going to write the coefficients of all the terms, lambda cube, lambda square, lambda, and the constant. So the coefficient of lambda cube is 1, the coefficient of lambda square is minus 6, the coefficient of lambda is 11, and the constant is minus 6. So the coefficient of lambda cube, lambda square, lambda, and the constant we have written here. Okay, by using the synthetic method, we will need to obtain the root. So the last term we need to multiply here by some value such that the multiplication and addition at the end of this term we should get the value 0. So if I take the value here 1, so in synthetic method what I'll do is, in the first step I'll write here 0. So I'll start with the value 0. So 1 plus 0 will give me 1. 1 into 1. 1 into 1 is 1. Minus 6 plus 1 is minus 5. Minus 5 into 1. Minus 5 into 1 is nothing but minus 5. Now we need to add this term. 11 minus 5 is nothing but 6. Now 6 multiplied by 1. 6 into 1 is 6. Now you can see the addition will become 0. So you can see that the root which we obtained is lambda equal to 1. So lambda equal to 1 is a root. So lambda equal to 1 is a root. And the other root can be obtained from this equation. So this can be written in an equation form. So the last term will always be constant. Then this term will be lambda and this term will be lambda square. So I'll write it as lambda square minus 5 lambda plus 6 equal to 0. So I have reduced the cubic equation into a quadratic equation. Now I need to get the value. So here you can see the coefficient of lambda square is 1. Here it is 6. So multiply both the values. So 1 into 6 is 6. So 6. So the value should be in such a case such that two numbers multiplied should give the value 6 and the addition should give me minus 5. So if I take 2 into 3 plus 6, it is given plus 6, no? So plus 6, 2 into 3 plus 6. But in addition, it should be minus 5. But if we add, we are getting plus 5. So try to change with the signs. So if we take minus, so if now multiply the terms, minus 2 into minus 3 is nothing but plus 6. Now if we add the terms, minus 2 minus 3 will get minus 5. Therefore, we have lambda equal to 1, the root which we found before, and then we have the value lambda is equal to, this is lambda minus 2 into lambda minus 3 equal to 0. So lambda equal to 1, and the next roots which we obtained this from here is lambda minus 2 equal to 0. So lambda is equal to 2 and 3. Therefore, we obtained the values of lambda. Therefore, the values of lambda are 1, 2, 3. So therefore, the roots of the characteristic equation is nothing but the eigen values. Okay. Therefore, the eigen values are lambda equal to 1, 2, 3. So these are my 3 eigenvalues. Now using these eigenvalues, I need to find the eigenvectors. So I'll write the heading here eigenvectors. So the eigenvectors can be formed using the equation A minus lambda I into x equal to 0. So I'll write here the eigenvectors can be formed using the equation is A minus lambda I into x equal to 0. So this is my condition to find the eigenvectors. So as I know the value of A minus lambda I. So first I'll write the value A minus lambda I now. A minus lambda I value is here, right? So I'll first write the value of A minus lambda I. So according to me, the eigenvector formula is A minus lambda I into x equal to 0. So A minus lambda I value here it is given as 2 minus lambda, 0, minus 1, 0, 2 minus lambda, minus 2, 1, minus 1, 2 minus lambda into the matrix x. X is nothing but x1, x2, x3 should be equal to 0. So now we'll multiply the matrix. So as you can see, it is matrix multiplication. So we'll multiply the matrix. The first row should be multiplied by the first column. So if we multiply, we'll get 2 minus lambda into x1 plus 0 x2 minus 1 x3. So this value will be equal to 0. So this is equal to 0. Next up, the second row should be multiplied by the column. So 0 into x1. So 0 x1 plus, this is 2 minus lambda into x2 minus 2x3 equal to 0. And then the third value will be, the third equation will be, the third row should be multiplied by the column. So this is 1x1 minus 1x2 plus 2 minus lambda into x3 equal to 0. Okay, so now we'll consider three cases here. So the case 1 is nothing but when lambda equal to 1. So we have got we got three eigenvalues, that is 1, 2 and 3. So I'm taking the first eigenvalue here. So this is my first eigenvalue, right? So I'll take the first eigenvalue here. So when lambda equal to 1, then a minus lambda I will be then no need to write this, girls, no need to write this. When lambda equal to 1, then according to the condition of the eigenvector, it is a minus lambda I into x equal to 0. So now substitute lambda equal to 1 in a minus lambda equation. So if we substitute, we will get when lambda equal to 1, then this equation will become, this is 2 minus 1, 0 minus 1, 0, 2 minus 1 minus 2, 1 minus 1, 2 minus 1. What I have done here, I have multiplied, I have substituted the value lambda equal to 1 in this equation. I have written here. According to the condition of the eigenvector, a minus lambda I into x. X is nothing but x1, x2, x3 should be equal to 0. And then first find this value. 2 minus 1 is 2. So 2, 0 minus 1, 0. 2 minus 1 is, 2 minus 1 is 1. 2 minus 1 is 1. 2 minus 1, 1 minus 2, 1 minus 1, 2 minus 1 is 1 into the value x1, x2, x3. So this is equal to 0. So now if we multiply, we get, so if we multiply this equation by this equation, the first row should be multiplied by the first column. So that is 1 into x1, 1x1 plus 0x2 minus 1x3 will be equal to 0. The second row will be multiplied by the column. This is 0x1 plus 1x2 minus 2x3 equal to 0. And the third row should be multiplied by the column. So this is 1x1 minus 1x2 plus 1x3 equal to 0. As you can see, all the three equations, all the above three equations are different. No equations are same. So I'll write this equation number 1, equation number 2, equation number 3. So I'll use the method of cross multiplication to obtain the value of x1, x2 and x3. So to obtain the cross multiplication, to obtain the value of x1, x2, x3, so I can consider any two equations. Okay, so I'll take the equation 1 and 2 here now. So using cross multiplication of equations 1 and 2, we get, so I'm going to cross multiply. So equations 1 and 2 I will take. So according to me, these are the first two equations. So first I will write the coefficient of the first two equations. The coefficient of the first equation is 1, 0, minus 1. And the coefficient of the second equation is 0, 1, minus 2. Now repeat the first two columns here, 1, 0, 0, 1. Whatever it is, repeat the first two columns. So for cross multiplication, how we will do is, so first we write here x1. So x1 divided by multiply these two terms first. So 0 into minus 2 is 0. Put minus here, and then the next value should be multiplied in this format. So 1 into minus 1 is minus 1. So minus 1. and then write equal to x2 divided by, for the next value you multiply these two equations. So minus 1 into 0 is 0. Put minus 2 into 1. Minus 2 into 1 is nothing but minus 2. Then put equal to x3 divided by 1 into 1 is 1 minus 0 into 0 is 0. Therefore, we will get the value x1 divided by 0 minus into minus is plus 1 equal to x2 divided by 0 minus into minus is plus. So plus 2 equal to x3 divided by 1 minus 0. So I'll have x1 divided by 1 equal to x2 divided by 2 equal to x3 divided by 1. Therefore the values of, therefore the first eigenvector is, therefore the eigenvector is, since this is my first eigenvector, I'll write x1, capital X1. So capital X1 is nothing but, the x1 value is 1, x2 value is 2, x3 value is 1. I'll write it in column wise. So x1 is equal to 1, 2, 1. The value should be written column wise, 1, 2, 1. Okay, so this is my first eigenvector. Now I need to find the second eigenvector. I'll write case 2 to find the second eigenvector. So for second eigenvector, I'll take the value lambda equal to 2, because we got the eigenvectors 1, 2 and 3. So we took the first one, lambda equal to 1 as case 1. Now for the second eigen value lambda equal to 2, I'll take it as case 2. Okay, so when lambda equal to 2, then a minus lambda I into x should be equal to 0. So according to me, I already have written here a minus lambda I. So if we put lambda equal to 2 in the above equation, we get 2 minus, the matrix will be 2 minus the value of lambda, the lambda value is 2. So I'll put lambda equal to 2, so 2 minus 2, 0 minus 1, 0, 2 minus 2 minus 2, 1 minus 1, 2 minus lambda, this into x1, x2, x3 should be equal to 0. So now I'm going to add and subtract. So 2 minus 2 is 0, 0 minus 1, this is 0, 0 minus 2, 1 minus 1, this is 0. So this is my matrix as I obtained after substituting the value lambda equal to 2. And then according to the condition of the eigenvector a minus lambda into x values x1, x2, x3 should be equal to 0. Now I am going to multiply both the matrix. So for multiplying, the first row will be multiplied by the column. So this is 0x1 plus 0x2 minus 1x3 equal to 0. Then the second row should be multiplied by the column. So this is 0x1 plus 0x2 minus 2x2 should be equal to 0. And then the third one multiplied by the third column. So this will be this will be 1x1 minus 1x2 plus 0x3. So this is equal to 0. So this is my three equations. As you can see here, the second equation, the value is, the coefficients are 0, 0, minus 2. If we divide this equation, by 2, we'll get 0x1 plus 0x2 minus 1x3 equal to 0, right? So as you can see, these two equations will be similar and this equation will be different. So what I'm going to do, to obtain the value of x1, x2, x3, we used a cross multiplication, right? So here I'll take for cross multiplication, I'll take the equation 1 and 3. Okay, because equation 1 and 2 will be the same. So I'll take equation 1 and 3. So this is my equation 1, this is my equation 2, this is my equation 3. So for cross multiplication, I'll take the equations 1 and 3 now. So I'll write the coefficient, I'll write here. So using cross multiplication, in equation 1 and 3, we get So 1 and 3, the coefficients first I'll write here. The coefficients are 0, 0, minus 1, 0, 0, minus 2. Sorry, 0, 0, minus 1, and the third equation coefficients are 1, minus 1 and 0. So this is my third equation coefficient now. Then for cross multiplication, the first two columns should be written again, should be repeated. So that is 0, 0, 1, minus 1. I have repeated here. So I am now going to find the cross multiplication. So here I'll write x1 divided by, so I'll start with the second column. So second column here is, the element is 0. So 0 into 0, 0. Put minus and then minus 1 into minus 1 is nothing but plus 1. And then I'll find the value of x2. So x2 divided by, multiply both the terms. Minus 1 into 1 is nothing but minus 1. Minus 0 into 0 is 0, equal to x3 divided by 0 into minus 1, 0, minus 1 into 0 is 0. So I can see here the values are x1 divided by minus 1 equal to x2 divided by minus 1 equal to x3 divided by 0. So here you can see the front value is minus. So we can multiply this equation by minus in the denominator. So the equation will become x1 divided by 1 equal to x2 divided by 1 equal to x3 divided by 0. So hence I can say that the second eigenvector is 1, 1, 0. Therefore, the eigenvector is this is my second eigenvector, so I'll write x2. So x2 is equal to 1, 1, 0. Okay, so this is my second eigenvector. Now I'm going to find the third eigenvector, x3. So case 3 I'll write, case 3. So according to me, the case 3, for case 3 I'll take lambda equal to 3. So the third eigenvalue is 3. So I'll take lambda equal to 3. Then according to the condition of the eigenvector a minus lambda I into x is equal to 0. So now I will substitute, as you can see, this is my a minus lambda I. So a minus lambda into x equal to 0. So in this equation I will substitute lambda equal to 3. If I substitute lambda equal to 3 here, 2 minus 3 will become minus 1. So the matrix will be minus 1, 0, minus 1, 0, minus 1, minus 2, 1, minus 1, and then minus 1 I'll get. So I'm substituting directly now, and then I'll write the value of x. So x value is x1, x2, x3. So this is equal to 0. So now I'm going to multiply both the matrix. If I multiply both the matrix, I'll get minus 1x1 plus 0x2 minus 1x3 equal to 0, and then 0x1 minus 1x2 minus 2x3 equal to 0, and the third one is 1x1 minus 1x2 minus 1x3 equal to 0. Here in this equation, here in the first equation, the negative sign is outside. So the first element should not be negative, it should be positive. So I'll multiply this equation only. I'll multiply this equation by minus sign. So if I multiply this equation by minus, the signs will change. So the negative will become positive. So I'll write this equation again. So this is 1x1 minus 0x2. This is plus 1x3. So the signs are changing, right? So minus will become plus, plus will become minus, minus will become plus. So this is equal to 0. The next two equation, the first term is positive only. The signs are positive, so I'll write it as it is. 0x1 minus 1x2 minus 2x3 equal to 0. Then 1x1 minus 1x2 minus 1x3 equal to 0. So this is my equation number 1, 2 and 3. Now I'm going to do the cross multiplication. So for cross multiplication, I can take any equations. So now I'll take equation 1 and 2. It's our wish. So using cross multiplication, On equations 1 and 2, we get so I'm taking the equations 1 and 2. So if I take the equations 1 and 2, you can see here the coefficient of the equations 1 and 2 are 1, 0, 1. For 0, the signs are not required. So I'll write 0 only here. And then the second equation is 0, minus 1, minus 2. I'll repeat the two columns, first two columns here. So that is 1, 0, 0, minus 1. Okay. Now I'm going to find the value of x1. So x1 will be x1 divided by, I should start with the second column. So 0 into minus 2. 0 into minus 2 is 0. Put minus. Minus 1 into minus 1 is minus 1. Minus 1 equal to x2 divided by 1 into 0, 0. Minus 2 into minus 1, minus 2. So minus 2 equal to x3 divided by 1 into minus 1, minus 1. Minus 0 into 0, 0. Therefore, you can see the values are x1 divided by 1 equal to x2 divided by 2 equal to x3 divided by minus 1. Therefore, the eigenvector is x3 is equal to, the values are 1, 2, minus 1. Hence, we got 3 eigenvectors. Therefore, the eigenvalues are 1, 2, 3. The eigenvectors are, we can say x1 is equal to 1, 2, 1. x2 is equal to 1, 1, 0. And x3 is equal to 1, 2, minus 1. So these are my 3 eigenvectors. So this is how you'll end the problem. I hope you can understand the problem. The question is very lengthy. The problem is very lengthy, as you can see. Eigenvalues and eigenvectors are very important. It will be asked for your 15 mark. So go through each and every problem in eigenvalues and eigenvectors. Most of the problems are different. According to the problem, we'll get different eigenvalues and different two methods to find the eigenvectors. So go through each and every step. Thank you so much for watching the video. Thank you so much. Have a good day. Bye.